let's move on to 3.2. And 3.2, I'm just going to talk about two specific theorems. That's it. Application of a differentiation. Still within application. That's called two theorems, Rolle's theorem and mean value theorem. Actually, they're the same theorem, but they're using the same conditions, but this is actually practically the same, but they have a different first derivative as their answer. So understand and use Rolle's theorem, understand and use the mean value theorem. That's the two things we're going to do. That's 3.2. Rolle's theorem. The extreme value theorem states that a continuous function on a closed interval must have both a minimum and maximum on the interval. Both of these values, however, can occur at the endpoints. We know that. We saw that yesterday. So Rolle's theorem, named after French mathematician Michael Rolle, gives conditions that guarantee the existence of extreme value in the interior or closed interval. So this is a Rolle's theorem. Let F be a continuous closed interval. This is an important class. Remember this. If F is not a continuous function, I cannot use Rolle's theorem. Rolle's theorem have a condition. What's the first condition? F has to be continuous on the closed interval. What else? It's a differentiable on a what? Open interval. There's two conditions so far, right? If you have that, then you can say if f of a and f of b, which means some value, I call it a and b. What they're saying is f of a and f of b will have what? Same value. Then there is what? At least
one number C.
One number C, such that what can you say?
F prime of C equals to 0.
Right. What that means what? Slope is what?
0.
Slope is 0, which means you either have what? Maximum or what? Minimum. We learned that from yesterday. Okay, so there's three conditions. What this condition says? F has to be continuous. F prime is F prime is also what? Exist. All right, differentiable and where? Open interval. What else? The f of a and f of b, the y value of endpoint has to be what? Same. Is everybody with me? The Rolle's theorem has three conditions. F is continuous, and it's what? F prime exists. What else? The endpoint of y value is what? Same. Then what can you say? There is such a number C of f prime, they give you what? 0, which means you with maximum or minimum. All right, this is what graph looks like. For example, this f of a is equal to what? So this value over here is a comma d. This value over here is what? B comma d, which is what? They both have the same y value. Is everybody with me? And they're continuous. It's differentiable. Then you have a what? The such number C. There exists X, which we call a C, okay? Specific number, critical number, such that they give you what? F prime equal to what? 0. So this is a perfect graph example of a Rolle's theorem. And this is another thing. Okay. This is a continuous function, but it's not differentiable where? Right here. So this is not really part of a Rolle's theorem, but we can still use it because we know there is what? Either maximum or minimum. I know some of you guys didn't sign this. Before you go, sign your name. All right, let's look at the example. Find the 2x intercept of 2x intercept of x squared minus 3x plus 2 equal to what? 0, in other words. And show that f prime of x is equal to 0 at some point between 2x intercept. Okay, first thing first. Is Does everybody agree this is a continuous function? It's a polynomial. So it's a polynomial, it's a parabola. It's a parabola, so this is, yes, it's a continuous function. Yes, it is differentiable. Is everybody with me? All right. So note that f is differentiable entire line. Setting f of x equal to 0 produces what? X-intercept, right? X-intercept means what? Means which one? You have some x, but y has to be equal to what? 0.
Set y
That's
to 0.
what the y, that's x-intercept means. So I'm gonna set this equal to what? 0. Then you're gonna factor this. When you factor this, you're gonna have x and x, -1 and -2. Does everybody see that? So you got this number, which give you what? X equal to
Positive
1. Or what? X equal to what? 2. All right, so we have a 2 intercept. So far so good?
Yes.
Okay. Now, let's plug it in. So you have this 2 number, right? Before I do this one, I want you to look at this. So you got this number here. So let's plug this number back into my f. What's my f of 1? Thank you, thank you. So what's f of 1? Okay, 1 squared minus 3 times 1 plus 2 gives you what? 2. So it gives you what? Is it 0?
Yes.
2 plus 1 is 3, 3 minus 1, 3 minus 3 is 0. Am I right, class?
Yes.
Okay, what's next one? 2 squared minus 3 times 2 plus 2, which give you what? 4 minus 6 plus 2 also give you what? 0.
Hey.
Are you with me, class? Hey, that means I can use Rolle's theorem, isn't it? Because Rolle's theorem says f is continuous, f prime exists, and what else? F of n point has to be same. In this case, they are also both what? 0. So the condition met. Rolle's theorem condition met. Is everybody with me?
Yes.
Okay. So that means since the Rolle's theorem met, I can what? Find a number C, right? A number C such that what? I can find number C such that that is equal to what? 0. Are you with me, class? All right, what's my f prime then? You know f is equal to what? X squared minus what? 3x. I forgot what other. What was my equation?
Plus 2.
Okay. So when you take f prime, 2x minus 3. Is everybody with me?
Right. Yes, ma'am.
So what can I do? I can set this equal to which number?
0.
0.
Andrew.
That's right, add 3. And 2x equal to 3, which means divided by 2, which is what? X equal to 3 over 2. That is my specific C. That's my critical number. Are you following me, class? So it says, then determine that f prime of x equal to 0 when x equal to 3 over 2. That is my critical number. So, right here, are you with me, class? That is where f prime is what? 0, which is you have, in this case, you have which what? Minimum. Is everybody with me? So Rolle's theorem telling you there is an x, there's a critical number such that what? The function has a minimum or what? Maximum. We don't know, but you will have at least what? Minimum or maximum. That's what Rolle's theorem telling you. Okay, now mean-value theorem. So mean-value theorem is just like Rolle's theorem, but just one thing is different. Look at this mean-value theorem. Let's look at our condition. F is what? Continuous. Same condition. Is everybody with me? What's next condition? Differentiable, which is same condition. But there's third thing is different. What is it? But then there exists a number C such that f of C is not equal to 0, but what is it? What is this definition over here? Can somebody tell me what this definition? What's this formula is? Equivalent to what that you know of? Slope, that's right. So this is the same as slope. they're saying I can find C, the number C, the specific number C, such that what can I say? The slope. This is equal to what? Slope. Well, f of A minus f of B is the same as what? Over B minus A, which is my slope. So graph looks like this. So mean-value theorem and Rolle's theorem is similar conditions, but what does it say? Rolle's theorem says one more condition. What's the Rolle's theorem? One more condition. Look at this one, class.
Your endpoints are even.
Right. The Rolle's theorem has one more condition. The one more condition is what? Your endpoint has to be same. But mean-value theorem doesn't say anything about that. It has to be continuous. It has to be differentiable. Then what can you say? There exists a number C such that f prime of C is the same as what? A slope. F of A, f of B minus f of A divided by what? B minus A.
Okay.
So for this function, f of x equals to 5 minus 4 over x. Find all values of C in open interval in this such that this is equal to 0. First thing first, does everybody agree? Let me look at my f of x. F of x is equal to 5 minus 4 over x. Can I rewrite it as 5 minus 4 over what? X to negative 1. Can I rewrite it like this? Because if I write this, I have to use the quotient rule. But if I make it into power, then I can use what? Power rule. Which is power rule is easier to do than what? Quotient rule.
Okay.
So what is my f prime? 5 is simply what? 0. This is what? Negative 1 times negative 4. X to the negative 1 minus 1 more power. Which give you what? 4 x to the negative 2, which is same as what? 4 over x squared. That is my f prime. Is everybody with me so far? Okay. Now what do I need to look for? I want this to be what? I need to find C. So now let's look at that. What is my f of 4? F of 4 means 5 minus 4 over 4, which is 5 minus 1, which is equal to 4. What's 5? F of 1 equal to 5 minus 4 over 1, which is equal to what? 5 minus 4, which is equal to what? 1.
So you're just plugging in
To
into
my
the original function?
Yeah, my original function. So this over here is actually same as what? 4 minus 1 minus 4 minus 1. It happens to be the same number, okay?
That's right.
It doesn't mean to be, but it happens to be the same number. So we'll have what? 3 over 3, which is equal to what? 1. Is everybody with me? So in other words, Rolle's theorem always has to be equal to 0, but mean-value theorem says what? Whatever the number. The mean. What's mean means, class? Average. Are you with me? So it's saying there's average number exists between A and B. There's
Okay.
average number.
I got you.
All right? So now, because of this, so I need to set this equal to which number now? 1. I want my f prime of C to be equal to what? 1. Are you with me, class? I'm finding the specific C that satisfies this condition. All right, so what can I do? I will multiply this by what? X squared, and multiply this by x squared. So I have 4 is equal to x squared. What's x equal to then? Square root of 4 plus minus. So which is x equal to then?
2.
Plus 2, and then what?
Minus
Minus 2. Have a 2 specific number in this case. So Rolle's theorem and mean-value theorem is very similar to each other. Are you with me? But Rolle's theorem guarantees there's a maximum and minimum if the condition met. The mean-value theorem says I can find your average in between A and B. The average is this number. With the slope is that number. In other words, tangent line. I can find your tangent line parallel to second line of A and B. I show you the picture. Is everybody with me? Did everybody see that? I didn't set this equal to 0. I set this equal to what? Whatever the number that I found here. Is everybody with me? Okay.
Yes.
Can I erase now?
Yes.
So let's go over what they're doing. So I found this. And then you found this. This is a graph. So you found right here, this is tangent line. Are you with me, class? That's your slope. I can find the tangent line that's parallel to the second line, which is your endpoints. I can draw a line through my endpoint, and I can find a tangent line. Well, this is a half. In other words, this is an average of these 2 points. That's what's called mean. Mean means average, mean by theorem. Rolle's theorem guarantees either you will have a maximum or a minimum. Are you with me, class? This is it. Sometimes they write mean by theorem as this. Does anybody see that, how they write this? Because mean by theorem says what? F prime of C is equal to F of B minus what? F of A over what? B minus A, right? Then what they say is, you know what, I don't want to write like that. I want to write down as, I want to find what is my F of B. In this case, what can I do? I can multiply by B of A. Is everybody with me? Then you have what? B minus A and F prime of A, C. And then you have what? F of B minus F of A. But if I'm looking for F of B by itself, what can I do? Add what? That's what you have here. Sometimes this is useful because you want to find your next value of F. Say you know endpoint of one endpoint, but you don't know the other endpoint. I can find it using this. Sometimes we use this. They're just telling you this way you can rewrite it. This is the way that we know, but if you want to, you can rewrite it like this.